Okay, we are going to finish reviewing for the comp exam. So if you have this paper out and you want to keep that out, you're more than welcome to. We are going to start off with the exponent rules. So number 6 and number 7 on your comp exam review. So exponent rules, there are 5 different exponent rules. And let's review those really quickly. Okay, so exponent rules. The first exponent rule is the multiplication rule. So if I had x to the n power and I multiply it times x to the n power, when you multiply, what do you do with your exponents? You add your exponents together. So this would be x to the m plus n power. We have the quotient rule. I'm sorry, that was called the product rule. I couldn't think of what the name was. It just came to me. Product rule. The next one's the quotient rule. If I have x to the n power divided by x to the n power, what do I do with those exponents for division? You subtract them. So this would be x to the m minus n power. I have the 0 power rule. If I had x to the 0 power, what's anything raised to the 0 power? 1. I have the negative exponent rule. If I had x to the negative n power, how do you fix a negative exponent? You got to move it, like if it's in the numerator, you have to move it to the denominator. If it's in the denominator, you have to move it to the numerator. So in this case, this is currently in the numerator, so I need to move it to the denominator, and I'm going to put a 1 on top. So 1 over x to the n power. And the last rule is power to a power. If I had x to the n power raised to the m power on the outside, I would multiply those. So this is x to the n times m power. Okay, so let's do some examples that have that in there. One thing about exponent rules is every single one of these rules in the order of operation fall in the PEMDAS, they all fall right here in the E section. So it doesn't matter which one you do first. Okay, technically you can do any rule in any order that you want to. It does help to do them kind of in a certain order. So lots of times we do this rule first, just because it gets rid of parentheses and it makes things a little bit easier. And then from there, I tend to always do my negative exponents second, just because it gets rid of all the negative exponents and then it's a lot easier to work with. Again, you don't have to do it my way. You can do it any way you want to, but it tends to be easiest if you do it in this first, this second, and then whatever you see from there. Okay, so let's start off with the problem. 3x squared y, all raised to the third power, times 2x cubed raised to the negative 2 power. Okay, so the first thing I want to do is get rid of the parentheses. I'm going to distribute this power into everything. So just a reminder, everything is by itself here. What is the exponent for 3? It just has like an exponent of 1. It's just like 3 to the first power. Yeah. The exponent for 2, I'm sorry, the exponent for x is 2. What's the exponent for y? 1. So when I'm multiplying that 3 in, I'm going to multiply that 3 times every single exponent in here. Okay. The biggest mistake sometimes with this is people thinking 3x squared is one thing. If it has a plus and minus sign after it, it is one term, and we just think of it as one term. But with exponent rules, 3 has an exponent of 1. It's by itself. X has an exponent of 2. It's not connected. Okay. So this now becomes 3 to the third power. X to the 2 times 3 would be 6th power. And y to the third power. I'm going to do the same thing over here in my other set of parentheses. The 2 has an exponent of 1. I'm going to distribute my negative 2 into both of those. Again, you don't have to do it in this order. If you wanted to fix the negative exponent first, you're more than welcome to do that. It doesn't matter. Okay. So 2 to the negative, I'm sorry, 1 times negative 2 is negative 2. And x to the 3 times negative 2 is negative 6. Okay. From here, I'm going to move my negative exponents. Right now, all of this is in the numerator. This one and this one both have negative exponents, so I'm going to move that down to the denominator. So this now becomes 3 to the third, x to the 6th, y to the third, over 2 to the positive 2, x to the positive 6. And then from there, you just see how you can simplify it. Okay, let's start off like making our numbers. What is 3 to the third power? 3 times 3 times 3? 27. And then the 2 squared on bottom is 4 on bottom. You notice I have an x to the 6th on top and x to the 6th on bottom. What happens to those? They essentially cancel out. They divide out. If I did my exponent rule here, I would subtract my exponents. And what's 6 minus 6? 0, and x to the 0 is just a 1. So I could technically multiply 27 by 1 if I wanted to. Okay, so the x to the 6 goes away. In this case, if you wanted to, you could also done it over here. X to the 6 and x to the negative 6, that's the product rule. I could add those together. 6 plus negative 6 is also 0. It goes away there. It doesn't matter where you do it at. Okay, so the x's are gone, and I'm just left with y to the third on top. And that's my answer. Questions about that? Okay, let's do another one. If I had 3x to the third over y squared, all raised to the negative third power, times 2x squared over y to the third, raised to the second power. Get started on that and see how far you can go on that. Okay, I'm gonna go ahead and start working it out. You can keep on going. And if you kind of went in a different order, it may not be able to follow kind of my work. So don't worry too much as long as we end up with the same answer. I distributed the negative 3 to everything and the 2 to everything on the inside. Now, technically right now, this is like one fraction, right? Because fractions, you just multiply across the top, multiply across the bottom. So I'm just going to move all my negative stuff. So this 3 negative 3 needs to move down. This x negative 9 needs to move down. This y negative 6 needs to move up. So when I do that, I'm left with 2 squared x to the 4th, y to the 6th, over 3 to the 3rd, x to the 9th, y to the 6th. Questions about that so far? And then from there, I'm going to simplify things. 2 to the Second power is 4. On bottom, 3 to the third power is 27. What happens to my y's here? They cancel out. If I subtract my exponents, I get 6 minus 6 is 0, which would just be like multiplying by 1. The x's, though, x to the 4th on top and x to the 9th on bottom. There's 2 ways you can do this. The first way kind of confuses me, so I don't like doing it. But you could do 4 minus 9. What's 4 minus 9? -5. And then you have to move that. The problem where I kind of mess up at that point is like, but where's it at? And where do I need to move it to? It just kind of messes with my head. So the way that I kind of think about it is I'm going to do 9 minus 4, and I'm going to put my answer where the bigger exponent is. Because the idea here is like this is 4 x's on top, and this is 9 x's on bottom. 4, 5, 6, 7, 8, 9. If I cancel them out, where's the leftovers going to be? On the bottom. So that's kind of what I think in my head. But feel free to do it however works best for you. So 9 minus 4 is 5, and so it's going to be x to the 5th on bottom. And that's the correct answer. Questions on how I got something, especially if you went a different way about it, it may be kind of confusing to follow along. If you got a different answer, do you see where you went wrong maybe? Or you have questions? Okay, we're gonna do one more. If I have the problem, 5xy to the 2nd power times 2x squared y cubed to the -1 power times 7x cubed y squared to the 0 power. Oh, wait a second. If there's a negative exponent, we just move it up or down depending where it is. Yes. Let me get a different sheet of paper. I'm gonna come back to this. I'm gonna pause on this just for a second. So yeah, if it was like, if you had x -4 over y squared, this -4, that's the problem. I would move it down to the bottom. I don't move the y squared. So it would be x to the 4th y squared on bottom with a 1 on top. That's how you fix a negative exponent. If it was 2x y to the -3 over z to the -5. The two problems here are the y -3 and z -5. So you just move this one down and move this one up. The 2x stays the same, so this would be like 2x z to the 5th over y to the 3rd. So yeah, the way you fix negative exponents is by moving them from where they're at. If they're currently on top, you need to move to the bottom. If they're currently on bottom, you need to move them to the top. Okay. Okay, so coming back to this problem, this end part right here, 7x to the 3rd, y to the 2nd, all raised to the 0 power. What happens when we raise something to the 0 power? It's gone, right? It turns into a 1. I don't actually need to write multiply by 1. Okay, so that's the nice part, is that's completely gone now. Okay, for these other ones, I need to distribute these exponents in. Just a reminder, the 5 has an exponent of 1, the x has an exponent of 1, the y has an exponent of 1. This 2 over here is an exponent of 1. So when I multiply them in, I'm going to multiply my exponents. This becomes 5 squared, x squared, y squared. When I distribute the -1 into this one, it turns them all negative. So this becomes 2 to the -1 power, x to the -2 power, y to the -3 power. And then from there, I need to move my negative exponents. These are all on top right now because there's no fraction, right? So I need to move all of these down to the bottom. So this becomes 5 squared x squared y squared on top over 2 to the +1 power. I could put the +1 on top if I needed to, or I don't have to. X to the +2 power, y to the +3 power. And now I can simplify. 5 squared is 25 on top. It's just a 2 on bottom. What happens with my x squared on top and my x squared on bottom? Cancels out, turns into a 1. I don't need to write it. Y squared on top and y to the third on bottom. Subtract them. So 3 minus 2 is 1. Where's it going to go, on top or on bottom? On bottom. So y to the first power on bottom. And that's your answer. Questions about that? Okay, so that was 6 and 7. You can go practice those on your own, and the answers are on the back. We did ones very similar to both of those. We're going to move on to 12 and 13, inequalities. Okay, so linear inequalities. Say again?
You said 12 and 13.
12 and 13, yes. Okay, so sorry, let me pull it up. So you solve inequalities the exact same way you solve equations. There's just one extra rule. Do you remember the rule for inequalities? Yes.
You change the sign if you have to move a negative, I think.
Yes. If you multiply or divide by a negative number, you have to switch, flip, whatever you want to call it, the inequality symbol. This is one of those rules that I feel like people struggle with because of the wording that we say. Like if we say flip the sign, does that mean change the negative positive sign? Does that mean turn the less than equal to greater than, you know, that's, I feel like that's what struggles with. So that's why I'm like really making a big deal about saying the inequality symbol. Okay. So if I had a problem, let's see, if I had -2, this would be number 4, -2 minus 6x is greater than 10. Okay, so I have two sides of this inequality. It's kind of like I have a line down this greater than sign right there. Okay, so I need to move the -2. I need to move the -6. The first thing you're going to do is move -2. How do I move -2? Add 2 to both sides. And so the -2 and the +2 undo each other, and I get -6x is greater than, what is 10 plus 2? 12. So now I need to undo the -6 being multiplied. I do that by division. So I'm going to divide both sides by -6. Did I multiply or divide by a negative number? Yes, -6 is a negative number and I divided it, right? It multiply or divide, either one. So usually you multiply or divide at the very, very last step. So that's when you do it, okay? So since this 6 is negative, I have to turn that guy around. That's what the rule says. Instead of being greater than, it's now going to be less than. Okay, so I get x is less than 12 divided by -6, -2. And on your comp exam, it's going to ask you for this answer. It's going to ask you to graph it on a number line and interval notation. So let's practice that. So if you graph this on a number line, I need to put -2 on my number line. A number before it would be like -3. A number after it would be like -1. Which way am I shading, to the left or to the right? To the left, because it's less than, okay? So I want to shade to the left, to the left. At -2, is that gonna be a bracket or a parenthesis? Or a circle, open circle, closed circle? It's a open circle because it's not equal to. I can't remember on Math Excel if it does circles or if it does the bracket or parenthesis. Has anybody done the review? The bracket or parenthesis? Well, it does. Okay, so we're gonna do that. I'm totally fine. If you're doing something for me on a test and you put a circle, that's totally fine. It's the same thing. But Math Excel is going to want you to put a bracket or parenthesis. Parenthesis is when it's not equal to. Bracket is when it's equal to. Okay, so if you needed to make a little note, less than or greater than, you use parentheses. Less than or equal to, greater than or equal to, you use brackets. Okay, in this case, I'm going to use a parenthesis. So I'm going to put a parenthesis at -2 and shade it. I was taught all growing up to do the circle thing, but this is nice when you go to write interval notation, because interval notation now, from left to right, where does this graph start at on the left? Negative infinity. Infinities always have parentheses. Where does it end at on the right? -2 with a parenthesis. So this is interval notation. So there's like 3 parts to that answer: this number line, the inequality, and the interval notation. Questions about that? Okay, let's do another one. I'm going to do one. So that was like number 12. I'm going to do one like number 13 now. A compound inequality. Okay, so a compound inequality is an inequality that has 3 different sides. It's like a 3-sided equation. Okay, so this problem we're going to do: 2 is less than 3x plus 5 is less than or equal to 11. There's 2 different ways you could do this. You could keep this all together and think of it as like a 3-sided equation. Okay, whatever you do to one side, you got to do to all the other sides, essentially. You could also, if you wanted to, break this apart into 2 different problems. Here's one problem. You could rewrite that over here and work that out. There's the other problem. Rewrite it over here and work it out. However you want to do it. It's up to you. I'm going to do it all together. Okay, so if I'm solving for x, I need to divide by 3 and I need to subtract 5. Which one do I do first? Subtract 5. I have to do that to all 3 sides. 2 minus 5 is -3. Less than sign. It's just going to be 3x in the middle. Less than or equal to sign. 6 at the end. How do I solve for x? Divide by 3. So -3 divided by 3 is -1. Is less than, x is less than or equal to 2. It's pretty straightforward and pretty easy to solve it like this. I will say though, if you needed to flip your symbols because you divided by a negative, that's when you really want to have the 2 different versions. Okay, so I'm going to go ahead and graph and write this in interval notation, and then I'll show you how to do it, break it into the 2 different pieces. Okay, just if you need it. You're probably not going to need it, but I just want to show you. Okay, so when I go to graph this, you read it as -1 less than x less than or equal to 2. When you go to graph this though, this tells you the 2 different sides of your equation. I have -1 over here. I have the 2 over here. Not your equation, your number line. Because if I read this right here, x is less than or equal to 2. Would that be a bracket or a parenthesis? Bracket at 2. Which way is it shaded? To the right or to the left? Less than's going that way, right? Okay, or correct, not right. Over here, this says -1 is less than x, or you could read it the other way, x is greater than -1. Is that gonna be a bracket or parenthesis? Parenthesis. Which way is that shaded?
Right.
To the right. So it's everything in the middle there. Okay, let me show you how to break that up into 2 different problems if you wanted to do it that way. Again, let me write it down again. It's less than or equal to 11. If I covered up that part, that's one of my problems. So 2 is less than 3x plus 5. Here's my other part of the problem. 3x plus 5 is less than or equal to 11. When you work them all out, subtract 5, divide by 3, you end up with -1 is less than x. Over here, subtract 5, divide by 3, you would end up with x is less than or equal to 2. And that's your two pieces that we had up here. Okay, so it's the same idea. It's however you prefer to do it. Okay, so that is number 12 and 13. Two more. Okay, slope and x and y intercepts. Let's go over slope first. To find slope of two ordered pairs, we need a formula. What's the formula for slope? That's the slope-intercept form, and we are going to use that next week. The other one to find slope is m equals y2 minus y1 over x2 minus x1. Okay, and x1, y1, x2, y2, that comes from two ordered pairs. Your two ordered pairs are x1, comma, y1, x2, comma, y2. Okay, so what if my ordered pairs were, this is number 6, 3, 2, and just a second, 7, negative 6.
Minus -6. -6 minus 2.
And for some people, they struggle with putting them in the right place. Like they get the problem wrong because they accidentally stuck something in the wrong place on here. So if it's helpful, you can label them x1, y1, x2, y2. And then when you go to plug them in, it's -6 minus 2 over 7 minus 3. What's -6 minus 2? -8. What's 7 minus 3? 4. If you can simplify that number, you got to simplify it. Okay. What's -8 divided by 4? -2. And that's your answer. Let me go over real quick all the different options that could end up as an answer. Okay. What if your answer ended up like this? 4 over -8. What's that answer? -1/2. What about if it was -4 over -7? How does that simplify? Yeah, negative divided by negative is a positive. So that would be +4 over 7. Does that make sense? Okay, so reduce it, simplify your signs if you can. Is it x2 minus x2 or x2 minus x1? You're right, sorry, thank you. I wrote that down wrong. It's x2 minus x1. I got a little excited or something. Okay, do we need to do another one like that? As long as you're careful plugging it in and you're careful with your, oh, let me go ahead and do one that is minus a negative. Okay. What about if it was, let's do the one at number 14. 5, -4, and -3, 3. Okay, so if you label them x1, y1, x2, y2. And then I plug them in. So y2 would be 3 minus y1 would be -4. So 3 minus -4 over x2 is -3 minus x1, which is 5. So 3 minus -4, when you are subtracting a negative, it's the same thing as adding a positive. 2 negatives make a positive, or a minus sign and a negative make a positive. Okay, so this would be 3 plus 4, which is 7. -3 minus 5, -8. Can I simplify that? Can you simplify your signs? No, so that's your answer. Questions about that? Okay, and you have a calculator. If you're struggling with that, the 3 minus -4, you can just type it in your calculator. 3 minus -4, and it'll give you your answer of 7 on top. Okay, last thing is x and y intercepts. What is an x-intercept? It is where your graph crosses the x-axis, and that is where your y value is equal to 0. What's a y-intercept? Where your graph crosses the y-axis, and x equals 0 here. So the way that I find x and y intercepts is I plug in 0 into the other letter. To find the x-intercept, you plug in 0 for y. To find the y-intercept, you plug in 0 for x. Okay, this also tells me that my ordered pairs are going to have zeros in it. For x-intercept, all ordered pairs that are an x-intercept is going to be something comma 0. All ordered pairs that are y-intercepts are going to be 0 comma something. And that's how you write your answers for x and y intercept, is an ordered pair with a 0 in it. So let's find, oh goodness, sorry. Let's find the x and y intercept of this problem. Number 1, 3x minus 7y equals 21. So to find the x-intercept, I plug in 0 for y. To find the y-intercept, I plug in 0 for x. So I have to do this problem twice. So to find the x-intercept, it's going to be 3x minus 7 times 0 equals 21. Seven times 0 is 0, and 3x minus 0 is just 3x equals 21. To solve for x, I divide by 3, and I get x equals 7. That's not your answer. Your answer is an ordered pair. How do I write it as an ordered pair? 7 comma 0. The x part is 7, the y part is 0. That's how I got the ordered pair 7 comma 0. Do the same thing, but this time plug in 0 for x. So 3 times 0 minus 7 times y equals 21. 3 times 0 is 0, so it's just going to be negative 7y equals 21. Divide both sides by negative 7. And I get y equals negative 3. That's not your answer. It's an ordered pair. 0 comma negative 3. And then it usually tells you to graph it also. Graph the line. So I have 2 ordered pairs that I can graph. So I put them on a graph. 7, 0. So go over to 7 on your x-axis, put a dot. That's your x-intercept. Y-intercept's negative 3, so I'm going to go down to negative 3, put a dot, and then draw a line. And that's your answer. Questions about that? Okay, that is all of the things.